I'm Anil Kumar, and in this video we will concentrate on three characteristics of polynomials. One is symmetry, the other one is degree, and then turning points. The question here is, graph of the polynomial is symmetric about origin. So let's make a note of this statement. Graph of the polynomial is symmetric about the origin. Does the graph have even or odd number of turning points? So trying to find, if we are given a graph of a polynomial which is symmetric about origin, then what should be the number of turning points? So that is how you need to understand the question, right? So first and foremost, if a polynomial is symmetric about origin, it means what? Is it even degree or odd degree function? This is what you need to figure out. So let me write down, take some time, you think, and let me know. Symmetric about the origin. So that really means the degree is odd. Therefore, it is odd degree polynomial. Correct? So that is the first thing. Now, once we know there's an odd degree polynomial, in that case, what could be the number of turning points? So now second thing is, so what could be the number of turning points? This is what you need to answer. Now it becomes simpler, correct? So if you examine, let me sketch few polynomials for you. So let's take x cubed, for example. So if I take x cubed, it will be kind of a function like this. So like this, right? So that is x cubed. So number of turning points is, let us write down. So let's write down number of turning points, right? So in this first graph, what we know is 0 is the number of turning points, correct? Now let me sketch another function which is odd, and we'll count the number of turning points. So let us say it is odd, so let me draw a function which is kind of like this. So if I draw a function like this, odd symmetry means I have to have a 0 which is symmetrical, and we are going through this. Now in this particular case, what you notice is that we have two turning points, right? So these are the two turning points. It is two turning points, correct? So this, we have two turning points. Now the question is, can you have one turning point? It is interesting. Now since the degree is odd, we are assuming for our sketches that the leading coefficient an is greater than 0, right? So right side up. This is what we are assuming for the time being. It could be less than, but I mean, the results are not going to change. But we'll concentrate more with right side up, an positive. Okay. The thing here is that if I have a 0 here, then if I have, let's say 0 on, there are two zeros. Since it is symmetric about origin, I should have two zeros here also. Is it okay? Since it is symmetry, right? Now that makes that if we are having a graph through these zeros, and if all the zeros are linear, then the graph will be kind of like this. Let me make a smaller graph here. Do you see that part, right? And let's count the turning points. 1, 2, 3, 4. So in this case, we get 4 turning points. So whatever conditions we have, we find that we always get even number of turning points. Well, some of you could argue and say, well, let's try turning it like a parabola. Okay, so if I use this turning point like a parabola here, right? So in that case, this turning point will be also kind of like this, symmetric. Is it okay? Right. So let's now go back to these, and oh, that is symmetric. Let's count the turning points. So we have 1, 2, 3, 4, 5, 6. So in this case again we have even number of turning points. As such, you will realize that if you're moving from quadrant 3 to quadrant 1, in that case, if you make one turn, you have to make another to reach to quadrant 1. If you make one more, you have to make another. So set of 2's, right? So therefore, it has to be even number of turning points. So what we get here is that we get even number of turning points. So always this number is even, and as you know, maximum, it could be n minus 1. Is it okay? Maximum is n minus 1. So that is what the result is, right? So whenever you have a function which is symmetric about origin, in that case the degree is odd and the number of turning points is even. So what we notice here is odd degree polynomial has even number of terms. Now that is true even for the polynomials which may not be having odd symmetry, right? So you'll note, let me write down here, which we'll explore in another video. We'll note that this is true for all odd degree polynomials. They may or may not be even. Do you understand? That is what I mean to say here. Okay, I hope that helps. Thank you and all the best.